In this quick video, I'll show you how to set up the arc length formula for a function. The arc length formula states that if f prime is continuous on the intervals a and b, then the length of the curve y is equal to f at x, where a is less than or equal to x and x is less than or equal to b, is defined like this. Now this application is used to measure the length of any curve. That's the purpose behind this, and the question reads, set up the function for the arc length of f at x is equal to x squared times ln x for x is equal to 2 to x is equal to 14. To do this question, we need to analyze what's happening here. We're being told that the length of a curve between two intervals a and b is equal to the square root of 1 plus the derivative of the function to the power of 2 dx. That being said, let's find out the derivative of f at x and apply it to this part of the formula. The derivative of f at x, which currently is x squared times ln x, is the following. And to do this, we need to use a combination of the product rule for derivatives and the power rule. The product rule tells us that if we have two products being multiplied to each other, for instance, we have the product x squared times ln x, we will find the derivative of this and then multiply it to ln x and then add the derivative of ln x to x squared. Let's go ahead and do that. F at x is equal to, I'm going to find the derivative of x squared using the power rule. That gives us 2x, leave ln x the way it is, plus leave this the way it is, and the derivative of ln x is 1 over x. Let's clean this up a little bit. We have 2x times ln x. We have x squared here, and one of these x's will cancel out with this x, leaving us with simply plus x. We just found dy over dx. Next, what we will do is substitute our derivative into here, where we end up with the length of this curve between a and b, and our a value here is 2 and our b value is 14. Lower limit of 2, upper limit of 14, the square root of 1 plus 2x, and make sure that that's in brackets, ln x plus x to the power of 2 dx. Now we have to find the integral of this function. Typically, you must integrate now, but they're usually hard to integrate once you've set up the function. So from here, you either do it numerically, or some questions just ask you to set the function up, and that's exactly what we just did. So I'll leave it at that, and there you have it. That is how to set up the arc length formula for a function.